Hey everybody, Doc here. We're going to look at our section 3 now, adding and subtracting polynomials, multiplying algebraic expressions, special product formulas, and factoring common factors. Factoring trinomials, special factoring formulas, and factoring by grouping. Now we're actually going to do the factoring by grouping before the factoring trinomials because I use a method that uses factor by grouping that I prefer. So an algebraic expression is a variable that can represent any number, so we often use x, that's our generic. Anytime we have a variable even by itself, or with constants and other operations such as addition, subtraction, multiplication, and division, we call those algebraic expressions. So here are some examples of algebraic expressions. This one has 3, this one has 2, and it has a square root in it, and this one is a rational expression. It has something on the top and on the bottom. However, if you were to have just a single expression, let's say you just had x by itself, that would be an algebraic expression, okay? That would be a monomial. And if you just had something like -2, I'll use a different variable, y, that would also be an algebraic expression, okay? So it doesn't have to be 3, 2, or a rational expression, but these two would be monomials. All right, let's move on. So a binomial would be 2 together, a trinomial would be 3 together, and then after that we'll just say it has 4 terms, 5 terms, 6 terms, etc. Now, the degree of an equation is the highest power that appears in the algebraic expression. So here I have 2x squared minus 3x plus 4. I have an exponent of 2. I have an exponent of 1. And technically I have an exponent of 0 here if I had x to the 0 power. So the highest exponent is 2. That's why over here it says the degree is 2. This is a trinomial because there's 3, and each one of these separate is its own term. Second is a binomial. It's a degree of 8. And here is 4 terms. The highest exponent is 3, so the degree is 3. Binomial, highest exponent is 1 on the x, so it's 1. This is a monomial by itself and has an exponent of 5, so the degree of 5. And this constant is also a monomial, and you want to think about it having an x to the 0 power with it. So since it does not have a variable with it, the degree is 0, because if you were to write one, it would have to be a variable to the 0 power. Adding and subtracting polynomials. We add and subtract polynomials if they have like terms. Like terms means that it would have the same base with the same exponent, same base with the same exponent, and then you would add the constants in the front. So this would be 8x to the 7th. And again, I know this is all review for you. Subtracting polynomials, you have to remember that a minus sign precedes an expression in parentheses. Then you have to distribute it to everything on the inside. So if it's out here, then the negative will come inside to both terms, and they will both become negative. However, if one of them is already negative, then it'll be the opposite of what it is, which then would be a positive. Okay, here we're going to have a couple examples. You can see we have some like terms here. I have an x cubed and an x cubed, so that'll be 2x cubed. I have a negative 6x squared, and a 5x squared will give me a negative 1x squared. I have 2x and a minus 7x, which when I add them will give me negative 5x, and then plus 4 by itself. Here, when I do the difference, I'm going to distribute the negative to each term in the second parentheses. So this first one will be negative, this will be negative, and this will become positive. So let's take a look. Okay, like we said, there's the above one. Now they're organizing them to be beside their like terms, which is fine, but it's not a step that you have to do. And then just adding them together, like we said, 2x cubed minus x squared minus 5x plus 4. The second one, when I distribute through the negative, again, this is now negative, this is now negative, this is now positive, okay? So it's the opposite of what it was. I'm going to organize my like terms and then combine them, and I have negative 11x squared plus 9x plus 4. Multiplying algebraic expressions. You probably have learned FOIL at some point in your math journey. So FOIL would be multiplying the firsts, the outsides, the insides, and the lasts. Okay, the other way of doing it is saying I'm going to take the very first term and multiply it by the entire second parentheses. That's what this stands for. And then I'm going to take the very second term and multiply it by the entire second parentheses. And then you just distribute it straight through. So this sometimes is easier to follow for people who don't prefer the FOIL method. In general, we can multiply two algebraic expressions using a distributive property and the laws of exponents. When we multiply trinomials and polynomials, we use a distributive property. So it is helpful to arrange our work also in table form. So you can look at both methods here. Here, finding the product, I would say 2x times this entire thing plus 3 times this entire thing. So let's take a look at that. There it is, 2x times this whole thing, 3x times this whole thing, or I should say times the whole trinomial. And then this shows you how it is distributed to each term. This step is unnecessary for you to show. And then organizing them into those expressions by multiplying these together. And finally, you're going to add like terms. Okay, so when I add like terms, I get 2x cubed minus 7x plus, or minus 7x squared minus 7x plus 12. All right, now you can do this in table form too. So if you put the trinomial on top and the binomial on the bottom, you can multiply like you would normally multiply numbers. So 3 times 4, 3 times negative 5x, and 3 times x squared. And then in the second row, you're going to start underneath where that term is, and you're multiplying 2x by everything. And then you have 2x cubed minus 7x squared minus 7x plus 12. So either way is okay, whatever way you like. Special product formulas. Now this I'm really going to push because you really need to know these special product formulas. Special product formulas save you a lot of time. So I notice right here that this is a difference of squares because I have the same thing in both parentheses besides one's plus and one's minus. I should be able to jump right to and say that that is a squared minus b squared. Here I have a binomial square. So I'm going to square the first term, I'm going to square the last term, multiply the two together, and then double it. Same thing here, but when I multiply the two together and double it, it will be minus because I have a negative. Now, I don't know if you had learned Pascal's triangle. I'll show it to you real quick. Pascal's triangle looks like this, so you'll recognize it right away if your teacher did this in your algebra class. It helps you organize when you're multiplying polynomials, and in a pinch, if you forget how to do a trinomial, you can quickly do this and remember, oh yeah, I have to have 1, 3, 3, 1 as my constants. You see up here, this is 1, there's a 1 right here, 3, 3, and then 1. Okay, and then notice that my exponents starting with my a start with 3, 2, 1, and then a to the 0, which means it's not there because there's a 1. And the b starts with b to the 0, b to the first, b to the second, b to the third. So that's a great way that you can remember how to do this. Now, if this is minus, the only thing you have to remember is that the terms alternate. So it starts with positive, then negative, then positive, then negative. Okay, key idea using these formulas is the principle of substitution. So if we have a squared plus y squared, and then this is squared, we remember that this part right here is our a, and this part is our b. And then I'm going to take that squared, I'm going to take my y cubed squared, multiply them together, and then double it. Okay, let's look at the special product rule for these. My a in the first one is 3x. My b is 5. So I'm going to square 3x. I'm going to square 5. I multiply 3x and 5 together, and then I double it. The second one, similar. My a is x squared. My b is -2 or 2. And then I have a cubed, so I know it is minus. If you know it's minus and you're using the alternate sign rule, you don't have to worry about whether the 2 is positive or negative. So here I'm just going to start with my first term, make it 3, 2, 1, and then x squared to the 0 means it isn't there. And then my second term, it's not going to be there because this is 2 to the 0. 2 to the first, 2 to the second, and 2 to the third. Then I'm going to stick in my coefficients, 1, 3, 3, and then you can see that there's really a 1 times this here also. And then once you simplify that, you'll get your result. So knowing the special formulas is extremely beneficial. I can't emphasize that enough. All right, factoring common factors. When we're looking at factoring, we're taking the binomial, trinomial, or polynomial, and we're factoring this way. If we start with this and we're multiplying, then we're expanding going this way. So we're going to take a look at factoring. So you want to look at the greatest common factor, the greatest common factor of all these terms. You're asking yourself, what is the same in all of these terms? Now, there's a way that you can do this, and I'm going to try to do it over here on the side. Hopefully this won't take up the room when the other part comes up. But if I have 8x to the 4th y squared, let's see, I'm going to put this here. My 8 is 2 times 2 times 2. And then my x to the 4th will be 4 x's. Sorry about my sloppy writing. There we go, that one's a little better. And then I'm going to have a y squared. I'm probably going to run out of room, so I might be defeating the purpose of showing you this way on here. If not, I'll show it to you on the document cam when we get together. Okay, and then I have the second one is 6x cubed y cubed. So I have 2 times 3, but my 3 is not in these numbers. So I'm going to stick it in the front, or you could stick it clear in the back, but you're not going to put it underneath anything that isn't the same. And then I have 3 x's, so I can line those up underneath these other x's. And I have 3 y's, so I'm going to line 2 of them up under the y's. And then the third one I'm going to put on the end because it's extra. And I don't have any more y's underneath. And then finally 2xy to the 4th. So I'm going to put the 2. You should kind of fill it in like, I guess it's the game Tetris where you fill things in first, right? I don't know if my memory's right there. All right, I'm going to fill in this x. Okay, and then I'm going to put 4 y's over here. And then I am going to put a 4th y on the end. All right, when I do this, if I bring down everything that is the same, I'm going to change colors. I'll make it, it says it's orange. I don't know about orange, but here we go. So here, this is a 2. I have an x that's the same in all of them. And I have y's that are the same here. And y's that are the same here. So you see that would give me my common denominator of 2xy squared, just like they said up here, by eyeballing it. Now, if you're good at eyeballing it, that's just wonderful. Keep doing that. But sometimes we need a little help when these get a little more complicated, and this is a fallback way that you can do it. Okay, so next, I'm going to take that out of each term. What's remaining stays inside the parentheses. And that's it. Now, see, the two terms have 2 common factors. Okay, so this is a new one where we have 2x to the 4th minus x minus 3 minus 5 times x minus 3. Now, if we see that they have 2 common factors, then we can actually factor these 2 parts out and put it over here. And then this is what's left on the inside. And then we're going to simplify that. And I would simplify that by 2x plus 4 minus 5, which is 2x minus 1. So I'd have 2x minus 1 times x minus 3. There we go. Simplify. Okay? So those are 2 or 3 actually different ways. And hopefully that'll help those. Now, factoring trinomials, I changed things around a little bit. We're going to look at the, lack of a better word, easier ones, simpler ones, and then I'm going to show you a method that I like to do for the others. Here we have factoring trinomials. This is only when you have a 1 in front of the x squared. What you want to do is you pay close attention to this sign and this last constant, and that will help you determine how to factor that. So if I'm looking at this, I'm going to go back to, I'm going to try a highlighter here. So this part right here is the most important part when you're factoring trinomials. What you're going to do, and this again is only when you have a 1 in the front of the x squared, okay? So this is for our simpler trinomials. Now what I'm going to do is I look at my factors of 12 and I ask myself, factors of 12 that I add together, and I'm specifically saying add because of this plus sign. So factors of 12 that I add together to get 7. So when I look at my 12, I know that I have 1 and 12. I have 2 and 6. And I have 3 and 4. And I'm asking the question, which do I add together and get 7? Well, obviously 3 and 4. So then I put my x here, my 3 here, my 4 here, and I'm adding the factors so they're both plus 3 and plus 4, okay? This will also tell me that not only am I adding factors, that the signs are going to be the same, and they will be whatever this first one is up here. So I'm back up here at the equation. So this tells me my signs are the same signs, and they will be whatever that first one is. And if you just learn these simple rules, it makes things so much faster for you. Okay? All right, I did 3 more examples here because I wanted to go over these with you. So let's take a look at x squared plus 7x plus 10. I look here again, I'm going to highlight this part of it. I'm asking myself, what factors of 10 do I hit highlight, I meant to hit the draw. What factors of 10 do I add to get 7? So those factors of 10 that I add to get 7 obviously would be 5 and 2. Okay, so I have 5 and 2. So then I have my signs are the same, and they're going to be what this one is. So when I factor this, I have signs the same. They're going to be plus. So I'm going to put my positive signs here. And then x, and x again, and we have 5, and we have 2. Now, since my signs are the same, it doesn't matter whether I put 5 and 2 or 2 and 5, okay? Either way is correct. Now, when I take a look at the second one, again, I'm looking this time, I have minus 10. So that tells me my signs are going to be different, and I'm subtracting factors of 10 to get 3. Well, I know I can see, and of course 1 and 10 is also a factor, but if I subtract them, I certainly do not get 3. And then there was 1 and 10 over here, and I kind of ignored that because I knew I wouldn't add it and get 7. So if you were wondering about that, you do think about it for a moment, but it doesn't work. Okay, so I have 5 and 2, and I'm going to subtract and get a positive 3. Well, that would mean that my 5 would have to be positive, and my 2 would have to be negative. So here I go. I have x in the front of each parenthesis. Now I want to emphasize again too, this is only when we have the 1 in front of the x squared. And then I'm going to place plus 5 in one, and minus 2 in the other. And I could have put x minus 2 first and x plus 5 second if I wanted to. Okay, and then another one here. And again, I'm hoping this is all review for you. Hopefully you're having a lot of aha moments. You're like, oh yeah, I remember this. And here I see 1 and 10 again, but obviously 1 and 10 I'm not going to subtract and get 3. Well, wait, I did that last time and got 3. It was 5 and 2. But what's different about this 3 this time is that it is negative 3. So I'm going to have the negative in front of the 5 and the positive in front of the 2. So again, x's are in the front. And this time I'm going to have minus 5 and plus 2. Now I could have put my plus 2 first if I wanted to. I have to make sure I keep those signs with the right numbers. And I could have put my x minus 5 in the second one. That would have been okay as well. Okay, so hopefully that was a good refresher for you. And let's take a look at factoring by grouping terms. Now I want to do this one first because I actually use this method when I factor trinomials, the other trinomials that we'll look at next. When you have a polynomial that has 4 terms, sometimes you can use factor by grouping. So here we have an example where we're looking at factor by grouping. So we're actually taking a look at these two first and these two second. So let's take a look at what we're going to do here. All right, here's the first one. They grouped them together with parentheses. That's all they did here was put these two in parentheses and these two in parentheses. And then you ask yourself, what is the same in both of these terms? And the answer to that is x squared. So you factor the x squared out of the first two terms. Then you go to the second part and you say, what is the same in both of these terms? And you see that there's 4 in both, so you factor out the 4 and you put it in front of what's left, x plus 1. Then you should notice right away that these are the same. So since they are the same, you're going to put them in one set of parentheses right here. And then you put what's remaining in the second set of parentheses right here. Okay, here's another example. Again, this time you have to be very careful because you have a minus sign here. So if I'm going to put them in parentheses, I've got to factor out that negative, which means that this right here will now become negative over here. The positive in the first part will become negative in the second part. So as long as you get that step, the rest of it is the same. I look at the first two terms. I see that there's x squared in both. Factor it out. I look at the second two terms. I see that there's a negative 3 in both. I factor it out. Well, I'll say 3 in both, not negative, because if I factor out a negative 3, then that goes back to positive, and that goes back to positive. So I misspoke there. So we'll just say 3, factor out a 3, and then we get x minus 2. Okay, notice, ta-da and ta-da, these are the same. So that'll be one set of parentheses, and my other set of parentheses is going to be the x squared minus 3. Okay, now I wanted to show you that because I actually use that method for trinomials and factoring trinomials using grouping. And the difference between what this one is and the last one is you'll see that there is a number in front of the x squared that's other than 1. So when that happens, then I can't just use my method before and say factors of 3 that I add to get 10. Obviously, it doesn't work. And so I need to use a different method. And the method that I like to use is factor by grouping. And how I do that is I'll bring down the end terms here. Now, if you're comfortable with a different way, you don't have to resort to using it the way that I do it. But if you never were really comfortable with guessing and checking and factoring trinomials, then feel free to grab this method and use it because it works all the time. So here, the first thing I did was I just simply brought down these two, okay? First step. Next step is I'm going to multiply these two together and I get 24. I'm just going to look at the number, not the variable. Okay, so just the constants. I multiply the constants together, I get 24. Now that I have 24, now I'm going to use my rules that I knew how to use before, and I'm going to say, I'm going to add factors. Add factors of 24 to get 10. Well, 6 and 4 add together to give me 10. And since this is positive, that also tells me that my signs will be the same rule as last time, and they're going to be whatever this first one is. Now I know this is a lot to take in, but the good news is this is a recording. You can go back and look at it again. Okay, so again, I have 8x squared, I have plus 3, and then I said factors of 24 that I add to get 10 would be 6 and 4. So now I just bring those down, plus 6, and I'm going to put my middle variable with it. So 6x plus 4x. Now what I just did is the hardest part. If you follow me to here, then you're golden, because the rest is factor by grouping, which you already know. So let's take a look at the first two, factor by grouping. And I say, what is the same in both of these? I see that there is a 2x, so I'm going to take that 2x out of the first set of parentheses. And that leaves me with x plus 3. Oh, I'm sorry, 4x. 4x plus 3. Okay, 4x plus 3. Okay, then I come over to the second part, and I look at both of them, and I'm like, really, there's nothing else that can be factored out of there. So when that happens, we are just going to put a 1, because 1 is a factor of everything, right? And then I write my 4x plus 3. Now I again factor by grouping. I see, oh, lo and behold, these two are the same, and I can factor my 2x plus 1 in one set of parentheses, and the second set of parentheses 4x plus 3. Okay, and that's it. So again, the only new part here is if you have never done this before in this way, this part up here is going to be the new part. And then after you learn how to do this new part, the rest is the same as factor by grouping. So let's try one more. Okay, here we go. I'm going to go back to bringing down the ends. So I have 5x squared, giving myself some room in the middle. And this time I have minus 6. And I'm going to multiply the two together. I'm going to place it right above it, and I see I have 30. I'm just looking at the constant parts. I'm not worried about the variables for now. So I have 30. So what factors of 30? Uh-oh, I see a little bit of a difference. Again, I'm using the same rules that I used before in trinomials. What factors of 30 do I subtract to get -7? And again, I'm using -7 here because I have -7 here. So factors of 30 that I subtract to get -7, that would be -10. Sorry, I'm getting a little sloppy. And then a +3. -10 and +3. Now, The next part is my suggestion. I always suggest that if you have one negative and one positive, you put the negative first, and then that just keeps you from having to factor out a negative in the second part for factor by grouping. Okay, so again, I'll just say if you have one negative and one positive, just put the negative first. Okay, and then if you need more explanation on that, we can go over it when we get together. All right, so here we have this. Now I'm done. Again, I'm done. I have factor by grouping, and factor by grouping was what we already went over. So I take my first two, and I say what's the same here in both. Then I'm going to take second two and say what's the same in both. So let's take a look. First two, I see a 5x. So I'm going to take 5x out. And when I do that, what will I have left? I will have x minus 2. And for the second part, I see that I have a 3. And if I factor 3 out, I have x minus 2. Okay, now, once again, I go back and look and I say, oh, these are the same. That makes me very happy. I go here and I take my parentheses and I have my 5x plus 3 and one set of parentheses. And my second set of parentheses, I have x minus 2. And there it is. So once again, if you can get the hang of this first part, then the second part is just like factor by grouping. No more guessing and checking. No more switching signs around. And you'll get it right every time. Okay, so this is their explanation for factoring trinomials. And here they want to factor each expression. Here we have a 1 in front of it, so we can say factors of 3 that we subtract to get 2. Hopefully you see that would be negative 3 and 1. And that's our trinomial there. Our second one, we can see that we have, this is kind of an odd one. You won't run into this too often. We have this squared, and then 2 times this, and then minus 3. So it's a trinomial itself, and you can take a look at it in the form as pretending it's an x squared minus 2x minus 3. So we just did the minus 3 minus 1 here, and then you would plug in your 5a plus 1 into these parts. And then you simplify, and you get 5a minus 2, 5a plus 2. Okay? Special factoring formulas. Okay, just like before when I said you really need to know the multiplying formulas, you definitely need to know these as well. And hopefully in your high school they drilled that into your heads. So the first one we should recognize right away is a difference of squares. The second one is a perfect square. The third one is also a perfect square, but we have a minus. And we called it binomial square going the other way last time. Here, when we have the difference of cubes, okay, difference of cubes, we're going to put our negative first. Whatever our a is here, b is here. Then you square a and b and put them on the ends, and then you multiply them and stick it in the middle. Now, for this negative, the negative is here. The rest are positive. If it is the sum of cubes, then the first sign is positive, and the next sign is negative, and the end is always going to be positive because you are squaring. So those are some tricks you can remember for that. All right, factoring each polynomial, we can see here the first one is the difference of cubes. The second one's a little bit more tricky, but if you take a look closely, you can see that this is actually x cubed, or I'll say x squared, because I do it the other way, x squared, and then raised to the third power. That would make it a sum of cubes. Ooh, that's messy. Let me do that a little better. Okay, so we have x squared to the third power, and then plus 8. So that would make it a sum of cubes. Okay, let's move forward. We see that the first one, I have my 3x is my a, my 1 is my b, so 3x minus 1. The 3x is squared, multiply them together in the middle, no doubling, that's only for the binomial square, and then plus 1 on the end. Okay. The second one, again here, just like we said, we have x squared, and that is cubed, so that makes our a x squared, so we have x squared plus 2. Whenever we start with a positive, our first parentheses positive, our next one is negative. So we have x to the fourth, squaring it on this side, squaring 2 on this side to get 4, multiply them together in the middle, and there you have it. Hopefully, your high school math teachers really emphasized knowing those. All right, trinomial square, recognize it as a perfect square. I notice my ends are perfect squares. This is a perfect square, and this is a perfect square. What is the perfect square of this? X. What is the perfect square of this? 3. If I multiply them together, I get 3x. If I double it, I get 6. Bingo. That tells me it's a trinomial square. And it'll factor into a binomial square that we looked at before. Here, if I take the square root of this, I will have 2x. And here I will have y. If I multiply them together and double it, I have 4xy. Now I just have to remember that my signs are the same and they're both going to be negative because this one is minus. Here my signs are the same and they're both going to be positive because this is positive. So there we have the first one, x plus 3 quantity squared. And then the second one, 4x squared minus 4x plus y squared is 2x minus y squared. Okay, sometimes we can factor an expression and it will factor again. So we want to factor it until it is completely factored. So for instance, this one, if I look at both of these right away, I can see that they have something in common. So I want to recognize that, and I have 2x squared that I'm going to want to take out of there first. So when I do that, well, before I move forward, let's look at the second one since it's right here. The second one, do I have something that's the same in both? I do. I have at least one x, and I have 2 y's. Okay, so that's going to be my first part, which is my common factor. So the first one, again, they take out the 2x squared, like we said, leaving us with x squared minus 4, and I should recognize right away that that is a difference of perfect squares, which will factor to be x minus 2x plus 2. The second one, when I go to the next slide, remember that we already did this and found y squared is common. There it is, xy squared. And I notice here, this is a difference of squares. We might say, what? It's to the fourth power. Well, the fourth power is a square. So this becomes x squared plus 2, x squared minus 2, and lo and behold, that is also a difference of squares. Reminds me of what my favorite math teacher in high school, he used to give us these problems all the time. So we would keep looking until we knew we were done, and then here we go. Okay? All right, now that is our last slide. There's a whole lot to go over. It's 45-minute voiceover, so I know that's a lot, but the benefit is you can go back and review this at any time you want to. I'll see you for the next one. Have a great day.